In this video, I'm going to analyze ore that was sent to me by Ryan, and he's ball milled it to a very fine powder. It's very much like talcum powder. The gold particles in here are minus 200, minus 300 mesh. I don't know, they're super fine. I'll try to make an estimate. We'll take some photographs and we'll make an estimate. So that's the job for today, is to run 500 grams through the table, figure out, and then run the tailings of that through the table again and figure out what we lose, and then do a little bit of analytical chemistry on it, semi-quantitative chemistry, and we'll see how it goes. So here's the ore, very finely ground. I've mixed it with some water and a little bit of jet dry to make sure that it's not hydrophobic. And I'll run it on the table. You notice I've made some table modifications. I wasn't able to get a neoprene mat made for this because the bloody neoprene comes curled up and it takes weeks for it to uncurl to be flat enough to use. So that's a bummer, but I'll try it on the table the way it is. I think if I set it up right, I should be able to get, I'm hoping to get 70-75% recovery from the first run, and we'll test that by running the table and then running the tailings through the table again, and maybe then again running the tailings. So we'll see how it works out. So I'm going to set the table up for a 2.5 degree slope, so a fairly gentle slope, and minimal water flow, just enough to get the light stuff separated and shed from the heavier stuff. All right, I've let the table clear. Didn't take long at all with that light material, and I'll pull the cons first. So out of 500 grams, that's what's left. I'll get that out and try to weigh it up. So that really light material, it just goes off as silt in the water supply, into the water. So there's what was in the cons port, came out of the cons port. It's still wet. That's 22 grams. So there's the 20 grams of cons. So started with 500 grams and we've got 20 grams of cons left. There's still a lot of light material in there. Okay, so there's what's left of the tailings. I don't suppose there's more than 100 grams left of the 500. So most of it is so light that it just goes off as silt into the water. I guess that's a good thing. All right, so here's the first pass cons. And I ran the tailings through the machine again, and this is the cons from the tailings. So now I'll do a little bit of cleanup with like a snuffer to get the heavy stuff out of here into a test tube. So here's a rough little video of the gold in the cons, and it's really quite beautiful. There are lots of tiny particles. I'll measure the size of the particles and we'll see what that is. Now here's a video of the tailings, and you can see there's not much there compared with the cons. Here's a side-by-side comparison of the gold in the cons versus the gold in the tailings, and I think you can see it's far less than 10%. I don't know what it actually is, but you know, as long as we're getting 90% recovery or higher, I think that's working quite well. Here's a photo of the gold with a scale superimposed at the same relative scale. The scale itself has 250 microns per division, and I estimate that most of the particles are actually under 50 microns, which is about 300 mesh. So I'd call this 325 minus, most of it anyway. Okay, so we're going to start the chemical analysis part of this. This is the material. This is the cons, and then the cons from the tailings. I just combined the two. This is a little field heater that I made. It has an aluminum tube in there. There are some resistors epoxied to that tube. There's insulation. It runs off of DC. I run it at about 10 watts. The battery I have is 300 watt hours, so this would last for 30 hours in the field. It's got a cover that prevents the wind, further insulation, and then that prevents the wind from getting in there. So the first thing I'm going to do is I'm going to clean this with just straight hydrochloric acid. And we'll cook that for about an hour, and that'll remove copper and iron compounds that we don't want when we do the chemical analysis. Okay, so I'm going to add hydrochloric acid. This is muriatic acid you get in the hardware store, 30% roughly. We don't have much in the way of cons, so I'm not going to add a lot. That's what, 15 milliliters. And I'll just let that cook for about an hour. This will bring the temperature of that fluid up to about 80 degrees centigrade, which is more than good enough for this. I've allowed the hydrochloric to react for an hour, and I'm going to pour this off, rinse well, and we'll start the aqua regia digestion. So let me rinse this out really well. Okay, all rinsed out. Now we're going to make aqua regia in there. I'm going to put on my respirator because I don't like these acids. Okay. I'm going to put in roughly 5 milliliters. Of hydrochloric. And there's very little gold in here, so I use very little nitric acid. I'm going to use 10 drops. There's 20 drops to a milliliter, so that's a half a milliliter of nitric, and that's more than enough. And we'll let all of that gold dissolve in the aqua regia. I reacted that for about an hour and 15 minutes, probably way more than enough. Anyway, all the gold is completely gone. So now I'm going to add urea to that. And here I've got a saturated solution of urea. At room temperature, that's 1.2 grams per milliliter. And I've done the calculation, and if I use the same number of drops of this as I did nitric acid, then all of the nitric acid will be killed by that much urea. Actually, it's overkill, but that's good. 1. Okay. So that produces a little bit of a fizzy reaction as the nitric is being consumed by the urea. So now there's no nitric left in there. It's cooled off so I can filter it, which will be the next step. I've got a bit of cotton in the bottom of this funnel, and we'll just pour that. You can see the solution is a bit cloudy. That's usually from silver chloride. I'll rinse that. You can probably see how clear that solution is. Now, the cotton does a great job at filtering silver chloride, but it slows down, so you have to be patient. This is like 1 drip every, I don't know, 5 or 10 seconds. So there's the level in the funnel, and when that gets fully filtered, I'll rinse it a little bit with some water to make sure all of the chloroauric acid is through the funnel. Okay, just a little bit of water to rinse that filter. I want to minimize the amount of water I use at this moment because we're going to test this for gold using stannous chloride. Okay, so here's the final and, of course, the most interesting step. We want to get an estimate of how much gold is in Ryan's ore. That's 500 grams worth of ore. That's chloroauric acid, and we've digested all of the gold that I could extract from it. So I'm going to use stannous chloride. Presumably this will turn purple. Brownish purple sometimes because it's got gold in it, and that gold will form a colloidal solution that has the optical properties of being purple in color. In this test tube, I'm going to use hydrochloric acid, and I'll put stannous chloride in there. So there's the stannous chloride. And so this tube will have hydrochloric, some drops of stannous chloride, and then I'm going to carefully add a standard solution of gold that I made. This is gold in chloroauric acid form. In other words, it was digested with aqua regia. And I double refined this gold, and so I know it's hyper pure. It's very, very pure. It's probably 3/9 pure. So this is my standard solution then that I'm going to use to compare the gold that's in Ryan's ore with the gold that's in my comparison solution. So once again, hydrochloric, stannous chloride, the same number of drops I put here as I put here, and then I'm going to add gold to that slowly until the density matches between these two test tubes. And then I can use this light to illuminate the background so that we can all, I just broke a beaker, so that we can all have a really good look at what's happening here. All right, first thing is to add hydrochloric, and we'll bring the level up to the same level here. The reason I'm using hydrochloric is because it keeps the pH and all of the ions the same as in the aqua regia. Because remember, I've killed the nitric in here, so there's really nothing in here. There's a little excess urea probably. There's some, but there's mostly just hydrochloric acid. So that matches that. Now I'm going to add stannous chloride, and I'm going to add the same amount to each tube. That's 5 drops. From experience, I know I need 10 drops. 6, 7, 8, 9, 10. All right, so I've got 10 drops in each one. Of course, there's no gold in this one yet, so it doesn't change color. But whatever impurity, the interesting thing is whatever impurity is in this hydrochloric acid that makes it slightly yellow, that impurity gets eaten up by the stannous chloride. So lots of interesting chemistry going on here. So we can see that we got lots of gold in Ryan's ore. I'm going to mix this using a trick from Roma set My Adventure. At least that's the first time I saw this trick. And I'm going to mix this one the same way. So now the question is can we see through, get the camera closer, can we see through Ryan's gold? Well, that's a good problem to have, but I can't see through this. So I'm going to have to dilute this carefully by some standard amount so that we can multiply by that dilution ratio to find the amount of gold. So let me take another test tube number 5, and I'm going to take and make these two equal. Of course, that is the easiest way to do business, is just to make things equal. Then I don't have to know the exact amount. I just know that I've cut this by a factor of 2. I'll add hydrochloric to bring this back up to the same level as this one. So now I've diluted Ryan's ore by a factor of 2. I still can't see through it, so I'm going to do the same thing again. And I'll add hydrochloric to bring it up again to the same level. So now we're all set up and ready to go. So now what I want to do is I'm going to add my standard gold solution, which is 10 milligrams per milliliter. So, and I'm going to count the number of drops it takes to make this look like that, at least roughly speaking. One, 2, 3. We'll start with 3 drops to be careful not to overdo it. And I got it right the first time. Okay, that never happens on video, but that's close enough. So it took 3 drops to get me close enough to there. So I diluted by a factor of 4, that would be 12 drops that it took. And maybe it's a little bit darker than that, not a lot. I'm looking at it by eye, it's not so bad. So maybe I'm gonna call it, let's call it 2.5 drops. Good thing I stopped when I did. Okay, so that's it. I now know exactly how much gold is in this sample, and I'll show you how the calculation is done. All right, so let's see if we can figure out what we did. We started with 500 grams of Ryan's ore, ball milled to, 300 mesh or something. We put it through the shaker table and we ended up with 20 grams of concentrated material. I snuffered that up, put it in a test tube. It was less than 1 gram. I then digested that gold that sat in there with aperija, and I turned it into chloroauric acid. I then put stannous chloride in the chloroauric acid to form colloidal gold. But we found that that was way too dense to look through, so I had to dilute it by a factor of 4 to get something I could measure the transparency of. I then made a standard comparison tube of hydrochloric acid, and then I added stannous chloride to that. In the meantime, I had a bottle of high purity gold in a form of chloroauric acid at a concentration of 10 milligrams per milliliter. So we had Ryan's gold, and then I added drops into the comparison tube until I reached the same density as the density in Ryan's gold in the form of colloidal gold. So the density is the same, so I know I had to add 2.5 drops, but I diluted by a factor of 4, so I really added 10 drops if I took the whole thing. So how much gold did I add to match the gold in Ryan's ore sample? So 2.5 drops, 1 milliliter is 20 drops. There are 10 milligrams per milliliter in my standard gold solution, and I had a 4x dilution. So if I just multiply all that stuff together and do the division, I get 5 milligrams of gold. So over here, when we had the original sample of colloidal gold out of Ryan's ore, that had approximately 5 milligrams of gold in it. So if we had 5 milligrams of gold out of 500 grams of ore, well, I just do that calculation. I find that it's 10 parts per million, or another way of saying that is 10 grams per metric ton, or about 0.3 or 0.33 troy ounces per metric ton.